in this video, we're going to work example problems where we're given an expression or a term, and we want to rationalize the denominator. So that means we want to remove any radicals from the denominators of fractions. And we want to do this because a radical in the fraction of a denominator is considered unsimplified. So like here, this isn't incorrect mathematically, but it's technically not, it could be simplified further. So we're going to look at some different scenarios where we can do this. So here's the most common, where you just have a simple square root in the denominator, but we'll do one here. You could see where it's a cube root, which people can forget that this is going to be different. It's not like we're just going to multiply by the cube root of y over the cube root of y. This wouldn't work. So it's a little bit different with if it's not a square root. We're also going to do examples like this where you've got you're summing or subtracting radicals in the denominator. So how can we remove all the radicals from this denominator? Okay, so but here's the most common form you'll see, and this is the simplest to do. So we just multiply by 1 in the form of the square root of y over the square root of y. And this removes the radical because y to the 1/2 times y to the 1/2, if you add the exponents, that's just 1. And that's the idea. You want to get the exponents on all of the terms in the denominator to be some integer. If it's an integer, there's no radical. Any integer, not just 1. So therefore, we've got 4 root y over y, and now that's considered simplified. Okay, yeah, here we can't multiply by the cube root of y over the cube root of y, because what is the cube root of y times the cube root of y? Y to the 1/3 times y to the 1/3 is y to the 2/3. We still have a radical, right? We need to get a integer exponent. So what we need to multiply by is y to the 2/3, because 2/3 plus 1/3 is equal to 1. Okay, so now what we get is 4, the principal cube root of y squared, and then, but what are we left with in the denominator? Like a y squared, y times y squared? No, it's just going to be y to the 1st, right? Y to the 1/3 times y to the 2/3. Okay, here we could just multiply by square root of x plus 1 over square root of x plus 1. So, okay, 12 is 4 times 3. So we could take out a 2 here. We're left with 2 root 3. Okay, and in the denominator we're just left with x plus 1. So now we can combine the square root here and the square root here and we've got 3 times x plus 1. And there we go. Okay, so yeah, what do we do here? Well, we take advantage of the fact that if we multiply this by the conjugate, it's going to be, so we've got, so this is a minus b times a plus b. And so the result we know is a squared minus b squared. Well, a squared is 15. The square root of 15 squared is 15. And the square root of 11 squared is 11. So we've got okay, so 15 minus 11 is 4. And we've got, let's see, and there we go. Okay, same idea here. Let's multiply by 1 in the form of the conjugate of the denominator. And so what we're going to get is this is a plus b. This is a minus b. So what we're going to get is x minus 5 in the denominator, and then we're left with up here and we can cancel out these x minus 5s. And there we go. Okay. Here we can multiply by one in the form of the conjugate of the denominator again. And so if this is a and this is b, then a squared is going to be 16 times 10, and b squared is going to be 4 times 5. Okay, so now in the numerator we've got, so 2 times 4 is 8, and then times 10, and then we're going to get, so 4 root 50, and then 12 root 50, and then 6 times 5. Okay, so let's see. We've got 80 plus 8 root 50 minus 30 over 160 minus 20. So 80 minus 30 is 50. Now here you've got 25 times 2, so we can take out a 5. And then, okay, so now we can factor out a 10. Okay. And there we go. Okay, here, let's combine this into one fraction. So let's make a common denominator. So multiply. Okay, so we're going to get 7x plus, and then 3x over here, and then divided by x root 3x. And so we get 10x over x root 3x. So 10 over root 3x. So now we can rationalize from here, multiply by root 3x over root 3x. You've got 10 root 3x over 3x. Okay, let's combine these into a single fraction. So we could do, let's see, root 7 over root 7. So we've got 5 minus 7 over w root 7. So minus 2 over w root 7. So now let's multiply by 1 in the form of root 7 over root 7. And we've got, and there we go.